Happy New Year everyone and welcome back. What I thought we'd do today is just fairly quickly go through what you need to know for organic chemistry. I know you did it at the end of last term, but I think it would be useful to have a refresher because this will be in your mock exam, and when you get back in to lessons there will be a test on this topic. Yippee. So, organic chemistry, what do we need to know? I'll go through it fairly quickly on the slides now, but obviously you can take some time, go through it in your notes, go through it on what you've got already, and you can obviously go through the PowerPoint. Rewind the video if you want as well. So, lots of options. So the first thing we need to know about is the formation of crude oil, and you need to remember that it's formed from tiny sea creatures and actually plants as well that fell to the bottom of the sea, got covered by mud. That mud turned into sedimentary rock, and pressure and high temperature caused the remains of the animals and plants to turn into crude oil over millions of years. Okay, the oil can get trapped under this rock, or in some places it seeps up through, and this means you need to have some sort of oil well that digs down through the sand and rock, or actually even right through water and so on, to get to the crude oil and natural gas deposits, or in general fossil fuel deposits. Now, crude oil is actually itself a useless mixture. It contains a large number of compounds that all have different boiling points. And it's a mixture. That is, the compounds that make up crude oil are chemically uncombined. And they're called hydrocarbons because they are made up of carbon and hydrogen only. Now, most of these hydrocarbons belong to one particular family of organic compounds called alkanes, and we'll get back onto those in a little while. But you need to make sure that you know how fractional distillation works. Basically, what happens is the oil is vaporized and then goes into a fractionating column or fractionating tower. And that tower is cooler at the top than at the bottom. And the different parts of crude oil, called fractions, are separated out according to their boiling point. They condense at different levels according to their boiling point. Those with low boiling points towards the top, higher boiling points down at the bottom end of the column. So a fraction is a part of the whole crude oil mixture, and a fraction is a mixture again, but a mixture with a relatively small boiling point range. And if you look on this QR answer to this question, it's quite important because this sort of thing comes up quite often on GCSE papers. How does fractional distillation actually work? And you can see keywords: crude oil turned into a vapor, and they are separated according to their boiling point. The different compounds condense at different levels. Big molecules at the bottom with high boiling points, small molecules towards the top of the column with lower boiling points. Now, the uses, we don't need to know a huge amount about the uses, but we do need to be aware that they are used widely as fuels. Okay, so this is an important question here. What are the main differences between the fractions at the top and at the bottom of the column? And if you have a look at the graphic here, that really summarizes very nicely those differences. The small molecules at the top, which turn to vapor very easily. It's a low temperature at the top there, look. Now, small molecules, low boiling point, light in color, easy to light and runny. And as you get to the bigger fractions at the bottom of the column with the higher boiling points, they're darker in color, harder to light, and this limits the use of some of them as fuels. And we'll talk more about that a little bit later. Okay, but that's an important diagram just to get in your in your brain. You won't need to memorize all the names of these fractions. Now, problems with crude oil. We should know that crude oil is a finite resource. That means it's running out. It's not being replaced. The conditions on the earth are no longer making fossil fuels. We should be aware of the products of combustion and the problems that they cause. Remember, carbon dioxide, greenhouse gas, carbon monoxide is toxic. Carbon causes global dimming, carbon particulates, also makes buildings filthy. Oxides of nitrogen, acid rain. Sulfur dioxide, also acid rain. Remember the terms complete combustion, that's for the formation of carbon dioxide, incomplete combustion for carbon and carbon monoxide. And we also need to be aware that nitrogen oxides are formed whenever oxygen and nitrogen, both from the air, are subjected to very high temperatures. And sulfur dioxide is formed by the combustion of impurities found in the fossil fuels, sulfur impurities in the fossil fuels. Now you need to know all about the alkanes. They're called saturated hydrocarbons. We know what a hydrocarbon is, mentioned it a little while ago, but this term saturated here is a fresh one to you. Saturated means it contains only single bonds. Okay, it's nothing to do with it being wet or anything like that. Nothing to do with solubility, but just contains single bonds. Now we need to be able to recognize this term here, homologous series, and that's the meaning of an homologous series. It's basically a family of organic compounds that all fit the same general formula. Well, that's CnH2n for alkanes. They show trends in physical properties, so boiling point increases as the MR increases, and they undergo similar chemical reactions. And their melting point increases with the relative formula mass. They get less volatile. That means they change state less easily as the molecule gets bigger. So we need to be able to recognize these alkanes. Believe it or not, you might get asked the question, what's the formula of methane? Being given that picture. Okay, easy peasy, CH1, 2, 3, 4. Simples. You might be asked to draw that. Remember, these lines represent a single covalent bond, so it contains only single bonds. The next one we need to know is ethane. Again, you might be asked to draw that, deduce the formula, and so on. Propane, butane, and pentane. General formula of an alkane, very important, CnH2n plus 2. You might be asked in a question, an alkane has so many carbon atoms, how many hydrogens does it have? Just double that number and add 2. You might get asked to work it the other way. It's got, I don't know, 18 hydrogen atoms, how many carbons does it have? So you have to be able to work back the other way. So what you would do, you'd take 18 minus 2, 16, divide by 2 to get 8. Okay, just got you to think about some of the similarities and differences between these molecules. Hopefully you did that, but the key difference to note is that thing there. It's not an equal sign, that's a double bond. So that means you've got carbon double bonded to a carbon, and the formula of this contains fewer hydrogens than the maximum number. This is a member of another homologous series. This is a member of the alkenes. Now, some of the fuels are very hard to ignite, or some of the large hydrocarbon molecules are hard to ignite. And they used to go to waste until a process called cracking was developed. And this is to help meet demand of these smaller, more useful hydrocarbons. Things used to make petrol and so on. The process by which that's made is called cracking. And cracking takes a long chain alkane that's relatively useless into smaller, much more useful alkane molecules for fuels and an alkene molecule. So there's a sort of general equation. Now, in the exam, you won't be asked 2 ways to carry out cracking, but the syllabus says you're meant to know 2 ways. But the way that I always find easiest to remember is vaporize hydrocarbons and pass them over a hot catalyst. And that would be the way, if we were in the lab today, we would be actually carrying that out. Heating the hydrocarbon to vaporize it, or vaporize them, and passing it over a hot catalyst. Using heat to break something down is called thermal decomposition. So cracking is a thermal decomposition reaction. There's the practical that we would do. Okay, can you deduce an equation for the cracking of C8H18? Well, it sounds difficult, and it's the sort of thing that does come up in the exam. It's actually easy. You've just got to make up the formula of an alkene. Could be C3H6. Subtract that, and you get C8H18 goes to C3H6 plus C5H12. So in the same way you need to be able to recognise the alkanes and know a little bit about them, same is true for alkenes. These are called unsaturated because they contain double bonds. Or, as I alluded to on a previous slide, they contain fewer hydrogen atoms than the alkane with the same number of carbon atoms. The preferred definition is contain double bonds. And that's easier than this slightly wordier one to remember. So unsaturated, contain double bonds, hydrocarbons. Okay, that's what unsaturated means. Now you can't have methane because you can't have just one carbon atom. So here you've got the simplest alkene is ethene. And again you need to be able to recognise it and draw it. Same for the next one, propene 2. Now sometimes you will see these these hydrogen atoms draw at an angle like that, as they're drawn here. Okay, just watch out for that. But very common mistake when people are asked to draw the formula out of propene, this sort of formula, structural formula, they put an extra H in here. Okay, don't do that, please. Make sure that at all times your carbons only have 4 bonds. 1, 2, 3, 4. Okay, 1, 2, 3, 4 for that one. So avoid that mistake, please. Okay, there are some more complicated ones, but we're unlikely to be asked much beyond ethene and propene. General formula of alkenes is much easier. It's just CnH2n. So double the number of carbons to get the number of hydrogens. Okay, alkenes are more reactive than alkanes, and we use something called bromine water to distinguish between them. You can watch the video on the presentation, but the long and the short of it is that there's no colour change from the bromine water for an alkane, and the bromine water goes from red-brown to colourless when there's an alkene present, okay? Do not write clear. You must write colourless. Clear will be marked wrong. Now, why do we bother looking at alkenes? Well, first of all, they're used to make polymers. You may remember names like polyethylene, polystyrene, and so on. Polyvinyl chloride, PVC. But you'll also come across the term polyunsaturated before, with certain plant oils. Okay, they're described as polyunsaturates, and they are meant to be much better for you than animal fats, so than butter. But there's a bit of a debate about whether that's the case or not. I wouldn't touch this particular lot of flora. It's slightly out of date now. Okay, next lesson we will be looking at a new topic. Be ready.